Hi, welcome back to Millikan Chemistry, Millikan's oil drop experiment. So what is Millikan's oil drop experiment? The oil drop experiment was an experiment which measured the charge of an electron. J.J. Thomson discovered the electron in 1897 using the oil drop experiment and found the electron to be negatively charged. But no one knew until the Millikan's oil drop experiment what was that exact electrical charge. So there's a couple things we have to look at. We have F up right here, and that means the force upwards equals the F down, which is the force down. And the force down, of course, would be gravity. So force up equals Q times E times F down, which will give us the mass. Therefore, Q times E equals M times G. So, again, let's look at some things here. Well, the mass of an electron we know is 9.109 times 10 to the negative 31 kilograms. Okay? We also know the pull of gravity on Earth, which is going to be 9.81 meters per second square. And we know the electrical field. The electrical field in this case is going to be 5.577 times 10 to the negative 11. Okay, so now all we have to do is find the value of Q. So I've gone ahead and rearranged Q times E equals M times G as Q equals M times G divided by E. So let's go ahead and do that. Q, which is our charge in coulombs of an electron, equals the mass of an electron. So we go 9.109 times 10 to the negative 31 times the force of gravity, which is 9.81, divided by our electrical field, which is 5.77 times 10 to the negative 11. Okay, so when we do that, what we get the number Q equals 1.602 times 10 to the negative 19 coulombs. So let's go put that value right there. Now, you say to me, could we find any one of these values when we have the coulomb? And the answer is yes. Let's go ahead and do a couple of those real quickly. So let me go ahead and erase a couple things here. And let me show you how we can reverse engineer this information and get the other values. Let's say, for example, let's find mass first. If we want to find the mass of an electron, let's see how good our reverse engineering does. So we're going to take this equation again right here, right? And we're going to isolate for M. So M now equals Q times E divided by G. All right, so when we get the mass, we don't know the mass. Let's just say, for argument's sake, we didn't know the mass of an electron. So what we do is, if we know the Coulomb charge, which is 1.602 times 10 to the negative 19, this is pretty cool how this works, times the electrical field, which is 5.577 times 10 to the negative 11, divided by our gravity constant, 9.81. When we do the math, we find out that this comes out to be 9.107 times 10 to the negative 31 kilograms. You know what? That 7 is pretty darn close to a 9. And that's within acceptable experimental value. So you can find the mass. What if we want to find, let's say, the gravity? We know that gravity is 9.81, but what if we wanted to prove it using this particular equation? All right, so watch this. Let's go ahead and erase this here again. It's all erased. This is pretty cool. Math is so cool. All right, so here we go. Watch this. Let's say we want to find gravity. Let's prove that gravity is real. And let's prove it's pull on Earth, right? So here's the equation that we're going to use here. So we're going to isolate for G. G equals Q times E over M, right? So gravity equals the Coulomb, 1.602 times 10 to the negative 19 times our electrical field, 5.577 times 10 to the negative 11, divided by our mass of an electron, which is going to be 9.109 times 10 to the negative 31. So when we do the math there, our calculations come out to be 9.81 meters per second squared. Hey, look at that. That equals this. Pretty awesome. But what if we wanted to find the electrical field? What if we didn't know what the electrical field is? All right, so let's go ahead and do that then. I'll calculate that. And then we'll go back and look at the oil drop experiment one more time, since we find out where these numbers come from. Okay, so now we're going to calculate for E. All right, I did a little bit there again, and I did a little bit too much of that, so that's right. All right, so now we just want to find E. Again, we're going to use this equation right here, okay? This time, we're going to say E, our electrical field, is going to equal M times G divided by Q, right? So E equals our mass of our electron, which we know is 9.109 times 10 to the negative 31 kilograms times the force of gravity, which is 9.81 meters per second, divided by our Coulomb charge of an electron, which is 1.602 times 10 to the negative 19. When we do this, we do the math, we see that it equals 5.577 times 10 to the negative 11. So now we know that all these numbers right here are sound. They work. All right, what about the oil drop experiment itself? What did it look like? Well, let me go ahead and try to draw that for you real quickly. Now that you've seen the math, let's look at how it was done. Okay, so basically what they did, remember this is 1909, so the technology is not the greatest, but it's not bad either. So what they did was they took two charge plates. And above the charge plate, they had a box. And this box had an opening here where they sprayed the oil drops. So this is your sprayer. They also had a microscope, kind of like lens, and they would stare right here into the electrical plate, the microscope. And this is someone's eye here, right? Okay. And then they had, of course, the oil sprayer here, and then this thing would spray oil in here like this, right? So they make these oil droplets, and then, of course, these oil droplets go through a little opening here, and they would have several of them fall. But then what they would do is they turn on the electrical current. Now, this electrical current was to like thousands of volts. Lots of electricity, right? Are running through here. So what it did was, gravity is pulling down on the droplet while the electrical field is being turned on and off, and it's holding the droplet in place. And what they do is they measure the amount of electricity that is going through here and determining how much charge it takes to hold one single oil drop with the electron in it completely like it's weightless, right? In the middle, like it's defying gravity. And that's basically what they did in 1909 to find out the charge of an electron. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Millikan Chemistry!